For this next one, I want to tell you what a generalized quadratic is. So that's what we're going to be talking about, is generalized quadratics. And it's this idea, a generalized quadratic is basically something like this. So suppose that you had x minus 3 squared plus 2 times x minus 3 plus 1 equals 0. Now, if you're going to solve it, one of the ways you could solve it, you could say, oh wait, I can square this out, I can multiply this by 2, I can add it all together, and I get a quadratic, and that would certainly work. But there's another way to solve it, and the other way to solve it is to say, wait, if I was holding my hand over these two pieces, and I told you that they're the same thing, and say, guess what they are? You'd say, oh, that's an x. It's a quadratic equation. But it's not a quadratic equation. It's an x minus 3 in this case. So what we do instead is we say, okay, so this thing kind of looks like quadratic. So what I should do then is use a substitution, which we call u substitution. And what we end up doing is we say, let's let u equal the thing that looks like x if it was a quadratic. So let's let u equal x minus 3. And if we do that, then this becomes u squared, and this becomes 2u, and we still have plus 1 equals 0. And this I can actually solve out. I get u plus 1 times u plus 1 equals 0, and I get u is equal to negative 1. Now that would solve out for what u is equal to, but remember u is equal to x minus 3 in the original thing. So what this tells me is x minus 3 is equal to negative 1. And if I add 3 to both sides, I get x is equal to 2. Now this actually gives me my solution, because 2 minus 3 is negative 1, negative 1 squared is 1. 2 minus 3 is negative 1, 2 times negative 1 is negative 2. So I got 1 minus 2 plus 1 is 0. So it actually does give me the solution to the equation that I have right there. And it works all sorts of times. So for instance, suppose that I had something like, let's see here, suppose I had x squared minus 1 squared plus 3 times x squared minus 1 squared, sorry, not squared in this case, and then I had plus 2 is equal to 0. Then I could let u equal the thing that looks like the x if it was a quadratic, and so then I get u squared plus 3u plus 2 equals 0. So this is u plus 2, u plus 1 equals 0. So u equals negative 2, u equals negative 1. And I can say that, well, that means that x squared minus 1 equals negative 2, and x squared minus 1 equals negative 1. Add 1 to both sides, and I get x squared is equal to negative 1. Add 1 to both sides, and I get x squared is equal to 0. This tells me that x is equal to plus or minus the square root of negative 1. And this tells me that x is equal to plus or minus the square root of 0. So this tells me that x is equal to plus or minus I, and this tells me that x is equal to plus or minus 0, which is 0. So the solutions for this are 0, I, and negative I. Now let's just check it. 0 squared minus 1 is negative 1. Negative 1 squared is 1. So I have 1 minus 3 plus 2 is equal to 0. That works. What if I plug in I? Well, I get I squared is negative 1. Negative 1 minus 1 is negative 2. Negative 2 squares to 4. Negative 1 minus 1 is negative 2. Negative 2 times 3 is negative 6. 4 minus 6 plus 2 is equal to 0. It actually gives me a solution. So these are the solutions to this equation. So for generalized quadratics, you're looking at something that looks like a quadratic, turning it into a quadratic, and then actually solving it out.